Okay, in this video, we're going to test and see if there's other congruence shortcuts. So number one, they're wanting us to try to see how many triangles we can compose that are different using the same segment, PQ, with the same angles, Q and P, or the same angle measures. So I'm trying to draw two different triangles here. I'm trying to set the same distance PQ as a segment, and then trying to add those angles on at each end. And it looks as though those two triangles come out to be congruent. This actually is an illustration of one of our congruent shortcuts, the angle side angle congruent shortcut, or angle side angle pattern. It's one thing we have to watch for when we're looking for congruences. For number two, they're giving us a side, and there's an angle that's hooked to the A part of the side, but then angle C is actually the opposite vertex angle of the triangle. So I'm trying to draw like A and C in here, and then or A and B, and then I've got angle C kind of floating up in there, then connecting them together. Now I'm doing the same thing over on the other side, and trying to get this little C floating up there. And again, it looks like these two triangles are going to be congruent. But this time, the pattern is an angle side pattern. So these two triangles are going to be congruent because of angle side. So as you either clockwise or counterclockwise, you're looking for one of these patterns. So angle side congruent shortcut. Let's look at number three now. Number three, they want us to see if these triangles or these figures have congruent triangles. And the best way to do that is by looking for the congruent shortcut patterns. We have angle side angle, side angle, side, side. SSA only works for right triangles, and it's called HL. And then AAA, all three angles being congruent, only works for triangles that are the same shape, but they don't have to be the same size, so they're not congruent. They're just similar triangles. So we're mainly looking for those four main ones, and then in right triangles looking for possibly HL. So let's see what we got. So in this triangle we got reflexive between the two sides. PT is going to be congruent. The two opposite sides, QOT and LP, are named as congruent. And then with the parallel lines, we have alternate interior angles that give us congruent angles. So if we check the angle measures out, those triangles are going to be congruent by angle side angle. We have to name them in the correct order. So if we're going P to I to T, we have to go J to O to P to name the congruence correctly. Whoop, I guess I missed on that one. Actually, it's not ASA, it's SSA, which only works for right triangles. So gotta be really careful on those. Looking at number four, we got vertical angles in the center. We got parallel lines with transversals. That gives us opposite base angle type angles congruent. So with those two congruent sides, we can use the angle at Y and the angle at Z with the side in between and call that angle side angle pattern. So those triangles are going to be congruent by angle side angle. Also, we could use angle side. If we use the vertical angle, one of the angles, and then the adjoining side to it, that could also be angle side. And in order, XVW is going to be congruent to XZY. Looking at number five, got the vertical angles at C. Those are going to be congruent. There's two sides marked as being congruent. And then we have parallel lines cut by transversals. So that gives us pairs of congruent angles. So we've got several ways of doing that one. We've got angle side, and we also have angle side angle. We don't have enough for side or side angle side, I don't believe, no. Looking at number six, PS is angle bisector. That gives us two congruent angles there at the vertex. And let's see, we have the reflexive side between the two, and we got the right angle. Right angle is congruent, so that gives us an angle side angle pattern. So P to Q to S or P to Q to R is going to be congruent to P to R to S. In one like number 7, a lot of times it's really helpful to separate those triangles that we're dealing with and draw them separately, sort of to scale and labeled correctly outside of the main figure, and then mark the congruent parts correspondingly. So the angle CAN is going to be congruent to angle RNA, so I want to do that. The two right angles are going to be congruent, and then that side AN is shared between both triangles. That's going to be reflexive also. So if we look at what we have there, we have an AAS pattern that shows us that the two triangles must be congruent. So those two triangles are congruent by AAS. Trying to do it nested on the diagram would be extremely hard. This is the best strategy to use for overlapping triangles, especially if those are the triangles that need to be dealt with in the congruence. Number 8 is a little bit confusing. EFGH is a parallelogram. Now, we haven't really studied parallelograms, but opposite sides are parallel, opposite sides are congruent. Alternate angles or opposite angles are congruent, and diagonals are going to bisect each other. So, but for this one, this wants to show that EQL is congruent to GQK. We've got the two vertical angles there that gives an angle for congruence. We've got that GQ is equal to AEQ, which means that segments are congruent. And what else have we got? So it gives us a side and an angle. And then because it's a parallelogram, we can just alternate interior angles there at G and E. And that's going to give us an angle side angle pattern. So these two triangles can be congruent by angle side angle. E to Q to L is going to be congruent to A to Q to K, or G to Q to K. Number 9, name pairs of congruent triangles, at least 3 pairs. There's some parallel lines there, so using the lines marked with the 3 arrows, we can use EB as a transversal and do alternate interior angles there. Let's see, what else could we do? We could also use DB as a transversal and do alternate interior angles there. We could go to maybe a different set of parallel lines. Like let's look at the the ones marked with 1 arrowhead. If we look at alternate interior angles there, we can see that angle AEB is going to be congruent to angle DBE, using those lines as parallel with the alternate interior angle. And so we're looking for like using the 3 parallel sides, and then the other one gives us angle CDB is also congruent to AEB and DBE. In number 10, we're basically looking at a translation. Those 2 triangles are congruent. If we look at the left-hand one as being the pre-image and the right-hand one as being the image, we want to find a couple of matching vertices. So if we look and see how A moved to become P, it looks like 10 was added to the X component and 4 was taken away from the Y component. So in vector notation, we would have a 10, negative 4 inside the brackets. So all we have to do to find the corresponding coordinates of the other points is add 10 to the X and take away 4 from the Y. So when we do that for B, we get 18, 9. And when we do that for C, we get 20, negative 7. The Q1 should actually be 9. and the other one might actually be 7.